So I'm going to create two lists here. One is a list of input columns. So here I'm saying train df dot columns. So from the training data frame or from the raw data frame, doesn't matter. They have the same set of columns. I'm going to pick from column number 1, which means I'm going to ignore the date, and I'm going to pick till the column number n minus 2. So I'm going to skip the last column, which is the target. So that's going to give me all the columns starting from location to rain today. Okay. And then the target column that I want to predict is rain tomorrow. In this case, there is just one target column, and generally in classification, there is just one target column. But sometimes there might be multiple target columns as well. So this could be target columns in certain cases. And another thing to keep in mind is certain machine learning algorithms expect you to always have a list of target columns. For example, linear regression does expect that, I think, but certain machine learning algorithms work fine with just a single value. So logistic regression, in fact, expects you to have a single target column. And that's why we're just picking a single target column here. Okay. So just be aware of that. Sometimes this may need to be a list. Sometimes this may need to be just a string. Sometimes it wouldn't matter. But this is the idea. We have input columns and target columns. So these are the input columns, just very explicitly printing it out. It's always a good idea to eyeball this and make sure, okay, I'm not using rain tomorrow as the target. And then we have the target column as well, which is rain tomorrow. Now, another special case of this is sometimes you may have columns which are derived from the target column. For example, you may have rain tomorrow and rainfall tomorrow in, let's say, in millimeters. So if you have a column rain tomorrow and you have a column rainfall tomorrow, then you probably don't want to use rainfall tomorrow as an input because you want to use a model with today's data. So you want to make sure that, and rainfall tomorrow is going to be a very strong indicator of rain tomorrow, but at the same time, it is derived information from rain tomorrow and it is not something that you will have in the real world. So be mindful of that. Sometimes some of these columns are derived or very closely related to the target and are targets themselves. So make sure to ignore those, right? If you want to use today's data, you pick just today's data. So that's your input columns and target columns. Now, once we have that, it's a good idea to just create separate data frames. So you have train inputs. Here I'm simply picking input columns from the training data frame. And I'm also just creating a copy because now we'll start modifying this data. We'll start doing scaling and encoding, etc. So I'm just going to create a copy so that the original data is not disturbed. And then we have train target. So here I'm just picking the target column. So here I'm picking columns. So train inputs is going to be a data frame. You can see here, train inputs. It's a data frame containing just the input columns, and then train targets picks single column. So it's going to be a pandas series. You can see that this is a series, and this series has just a bunch of yeses and nos. Similarly, we are creating validation inputs and validation targets. We are creating test inputs and test targets, and we can see what they look like. So these will either, mostly all the inputs are going to be data frames or sometimes NumPy arrays. And then the targets could be series or they could be data frames. And if you're ever in doubt, you can always just check what the type is. So this is a series, but the general rule of thumb is when you're picking multiple columns or a list of columns, that's when you get a data frame. When you pick a single column, you get a series. Okay. One other thing that will be useful is to identify which columns are numerical and which ones are categorical. This will be useful later because we will need to convert categorical data into numerical data for training a logistic regression model or any machine learning model. So if we look here, these seem to be numeric and then this seems to be categorical. I don't know, maybe this is also numeric, but then this is definitely categorical. This is definitely categorical. This is definitely numeric. So there's a combination. In fact, location here is definitely a categorical column and it has a grand total of 49 categories. And obviously location is a big factor because the weather or the climate of each location is definitely different. So as long as we are predicting just for these same locations, location is an important factor to look at. And by the way, you should also now understand that because we are using location as an input, your model can only make predictions for locations that it has already seen. Now, if you use this you cannot use this model for New York because your model does not know what to do with New York as an input. It has only seen location as an input. So if you want to create something generic, something that works irrespective of location, then you will have to remove the location column, right? So keep that in mind. On a case-by-case basis, you'll have to figure out whether to use it or not. For now, we'll assume that we are going to use the model for predicting these same locations most of the time. So we will retain the location column. So here's a quick trick to come up with numerical and categorical columns. So if you take a data frame and then call select D types and simply give it which type of columns to include. So here we have said include np.number, and then you can get the list of columns. So basically this selects just those columns of data in the data frame where they are numeric, and dot columns gives you the name of the numeric columns. And then we're just converting them to a list. So I think we should remove this as well. And that should give us the numeric columns. So let's see, numeric calls. So these are all the numeric calls: minimum temperature, maximum temperature, rainfall, evaporation, sunshine, etc. Okay. All I've done is I've selected the columns which have a numeric type np.number, and I've taken the list of that columns and I've converted it into a list. And similarly for categorical, we have selected the list of columns with data type object, and we've converted those to list. Now I was able to do this because there are no string columns in this data set, but if there were string columns, then we would have to do something more interesting, or maybe we would have to manually type out categorical columns. And you can, by the way, you can do that as well. That's completely fine. There are just 23 columns, so you can manually type out the names of numeric and categorical columns. Okay. So that's numeric and categorical columns. Here's numeric columns: min, temp, max temp, rainfall, etc. And as soon as you have numeric columns, you can also very quickly check some statistics by calling .describe. So here we are just selecting the numeric columns from the training inputs, and then we are calling .describe just to explore, okay, what does the ranges of these values look like? What's the minimum? What's the maximum? What's the standard deviation? What's the median? So it seems like minimum temperature can go up to -8 and maximum temperature can go up to, so the minimum temperature can go from -8.5 to 33, and the maximum temperature goes from -4 to 48. And this is also a good opportunity for you to see if there are any values that don't make any sense at all, in which case we may have to maybe do some, fix some incorrect values in some way, maybe draw some more histograms, etc. Okay. Yeah, but these values look fine to me, so I don't think there's a lot of data cleaning required here at this point. So that's the numeric data. And let's also check the categorical data. For the categorical data, it's a good idea to check how many unique categories there are. And this will also let you verify if all these are actually categorical. For example, location, there are 49 values. That may seem like a lot, but we are dealing with 140,000 rows of data here. So 50 is still, I think I would still call it categorical. I would not call it a string. But if I had maybe a 5,000 or 10,000 different values, then maybe that's better suited as a string column and not a categorical column. Then we have wind direction. We have 16 values for those. Well, that's just simple directions, and wind direction at 9 a.m., 3 p.m. And finally, we have the rain today column, which is also a categorical column. Yes and no. And rain today, I'm sure, is going to be very helpful in predicting whether it's going to rain the next day or not. Okay. So that's just identifying the input columns, target columns, and within the input columns, the numeric columns and categorical columns. And the reason we've done this is because we'll now start doing some processing with this data. Now, machine learning models cannot work with missing data. Whenever you have a NaN and you try to train a machine learning model, it's probably going to crash. So you need to fill these missing values with some valid values. And the process of filling missing values is called imputation. Now, there are several techniques for imputation, but we will use the most basic technique here. And I'll let you check out some of the other techniques, and we will try out some other techniques over time. But the most basic technique is to replace missing values with the average value in the column. And you can do this using the simple imputer class from sklearn.impute. So what we want to do is we want to replace this NaN with the average value in this column. And I think the average in this column, if we have just 3 rows, is 17 plus 5, 22 by 2, 11. So we have 11 here, and the average in this column is 6. So we have 6 here. The average in this column is just 7. So we'll just put 7 here. So this is just a guess. It's obviously may not be correct, but you have a choice here. You can either throw away those rows, but if you have a lot of NaN values in a certain column and you throw away those rows, you may lose a lot of data. So you just take a guess there and you think that, okay, maybe I replace it with the average, sometimes you may choose to replace it with not the average, but maybe a fixed value